Hello guys, welcome to Ramta Solutions. As promised, I promised you that we will look at factorial notation. So let's not waste any time and head straight into it. Now, I want us to imagine a situation where we have a family of 4 siblings and we want them to sit on a bench. Okay? We want them to sit on a bench. So the question is, how many ways can we arrange these 4 siblings? I want us to call them sibling 1. Let me change the color. I want us to call them sibling 1, sibling 2, sibling 3, sibling 4. Or maybe let's call them A, B, C, D. I think for convenience, let's call them A, B, C, D. Okay? So we will call them A, B, C, D. So let's say now we begin by saying sibling A sits, followed by B, followed by C, followed by D. Okay, remember, we just seen how we can arrange them. Okay, and we will be using factorial notation, and you will understand this later on. Okay, then, yes, let's do it in this way. However, you can also say because you did counting principle, it's also easier for you, all right? But it's okay, let's proceed. So it's A, B, C, D. We can also have it as A, B, D, C, and then we can see it A, and then C, B, D, and then A, C, D, B, and then we can have A, D, B, C, and then A, D, C, B. Right? Perfect. What if it's sibling B that sits first? Okay, that's fine. It's B, A, C, D, or B, A, D, C, followed by B, maybe B, C, A, D, followed by B, C, D, A, and then B, D, A, C, followed by B, D, C, A. Okay, that's fine. Now, sibling C that sits first, C, A, B, D, C, A, D, B, or C, B, A, D, C, B, D, A, C, D, A, B, C, D, B, A. Right? Now, we can also have it in this way, where we can say we have D, A, B, C, and then D, A, C, B, or D, B, D, not B, D, B, A, C, and D, B, C, A, and then D, C, A, B, lastly, D, C, B, A. Okay? So when you look at it, this is 6, 12, 18, 24. So we can arrange them in 24 ways. Okay? We can arrange them in 24 ways. However, I have taught you that it is not necessary to be going this route. We will use counting principle, okay? We will use counting principle. So using counting principle, maybe let me change my color because it's already red here. So using counting principle, let me change my color. Using counting principle, we won't be having these things that we just did here. Okay, so using counting principle, we will say, okay, so there are 4 siblings, 1, 2, 3, 4. For the first seat, we will say all of them must stand up. And we say, all of you stand up, it's 4. So we have 4 to choose from for the first seat. All right? And then one of them sits. When one of them sits, we are left with 3 for the second place. And then we choose, maybe B, sit down. And then we choose one of the 3. Then when the first seat and the second seat has been occupied. How many siblings do we have? Now we are left with 2 siblings. Now for the third seat, there are 2 siblings left. So one of them sits. When one of them sits, obviously the last one has to sit. Therefore, what do we have? We have 4 times 3 times 2 times 1. And what is our answer? It is 24 ways. So there are 24 ways in which we can arrange these 4 siblings. Okay? There are 24 ways in which we can arrange these siblings. Okay? All right. I hope you guys are happy. If you like, you can put your multiplication here. Nothing wrong with it. It's okay. But I also advise that you do this as well. But obviously, say number of ways equals 4 times 3 times 2 times 1. It's okay. All right? Now, you have seen this even in the last video. But now let's proceed because we are looking at a factorial notation. So, now what you have seen, you saw that for the first sitting, there were 4 siblings to choose from. And one of them sat and we were left with 3 for the second sitting. Right? So for the second sitting, we have 3 siblings to choose from. Alright? Now one of them sits. Now that means for the third sitting, we are left with 2 siblings to choose from. Alright? Now, when one of the 2 that are remaining sit on the third sitting, we are left with 1 who will be sitting on the 4th sitting. Alright? So this is basically your factorial notation. So when you look at it, you're like, oh, okay, this is event 1. Event 1, you have 1. Look at it, guys. You have 1. By the way, I don't know why I'm saying an alternative way of calculations, which I did in the previous slide. You have, for event 1, you have 4 to choose from. For event 2, you have 3 to choose from. Right? For event 3, you have 2 to choose from. Then for event 4, you have 1 to choose from. Okay? And this is what led to 24 ways. All right? This is what led to 24 ways. Okay? Now, this is factorial notation. Okay? This is factorial notation. So, with factorial notation, what we are basically saying, I want you to pay attention. We're saying occurrence of the first event reduces outcomes of the second event by 1. Pay attention. The first event had 4 outcomes, but its occurrence reduces that of the second by 1, meaning it was 4, now the second will be 3. And then that of the second reduces the third by 1, and so on. So you can imagine it to be like this. You can say this is basically n times n minus 1 times n minus 2 times n minus 3 times and so on. All right? And this is what we call n factorial. All right? This is what we call n factorial. So this is factorial notation, where this n is the number of outcomes. Okay? Where this n is the number of outcomes. Okay, guys. So this is your factorial notation. Remember what I had said. Occurrence of the first event reduces the outcomes of the second by 1. Occurrence of the second reduces the outcomes of the third event by 1, and so on. All right? As you can see, there were 4 at first. So for the second event, it will be reduced by 1, meaning the second will be 3. The third will be reduced by a further 1, meaning it will be 2. The fourth will be reduced by a further 1, making it 1. Can you see that? This is factorial notation. Okay? This is factorial notation. Okay? Perfect. So instead of writing 4 times 2 times 3 times 1, you can simply write 4 factorials. Okay? You can simply write 4 factorials. Okay? All right. So this is it, guys. You will see the beauty of this factorial notation shortly. So let's proceed. Now we are trying examples. You have seen Florida before, right? You have seen Florida before. Now the question says, how many word arrangements are possible from the word Florida if the letters may not be repeated? In the previous video, I said Florida is made up of 7 letters. When you recall, I said it was 7 places. So it was 1, 2, 3, 4. Let me use a red color. Or maybe let me try green. 1, 2, 3, 4, 5, 6, 7. For the first place, it's 7. For the second, 6, 5, 4, 3, 2, 1. Remember, letters may not be repeated. So, what do we mean? When you want to know how many arrangements are possible, you can simply say it's 7 times 6 times 5 times 4 times 3 times 2 times 1. What is this? I remember saying to you, this is equal to 7 factorial. Alright? I remember saying to you, this is 7 factorial. Now to represent it, you will simply say 7 factorial, which is equal to 7 times 6 times 5 times 4 times 3 times 2 times 1. And you take your calculator. If you are using Casio, or I don't know where's my Casio, but please look for this option here. Look for this option on your calculator. It must be somewhere on Casio. It must be somewhere on the top, somewhere on the top right, just below your on and stuff. Okay? And then if you're using sharp, you must say second function 4. Okay, if using sharp, it's second function 4. Okay? If using sharp, it's second function 4. So, now take your calculator and say 7 factorial. When you take 7 factorial, you will get 5040, I believe. 7 factorial must be 5040. So it's 50,040 what? Words or word arrangement. Okay? Word arrangement. Sometimes I like telling students that when they say how many word arrangements are possible from the word, but I will teach you this one later. The permission NPR and NCR, I will show you this later. Okay, I will show you this later. So for now, I will leave it here. So this is how you answer the question using a factorial notation. Okay. Perfect. Now, it gets interesting. In how many ways can we arrange 6 athletes on the tracks? There are 6 athletes. So obviously, when we say there are 6 athletes, it will be 6 factorial. Let's see, this is 6 times 5 times 4 times 3 times 2 times 1. Take out your calculator and say 6 factorial. This will be 720 ways. So there are 720 ways in which we can arrange our athletes. I repeat, there are 760 ways in which we can arrange 6 athletes on the tracks. Okay. Now, I need to fix number 3. In how many ways can we choose the top 3 athletes? It needs to be, in how many ways can we choose the top 3 athletes from 6, from, I don't know why this one is showing. Okay. From, let's say from 6 athletes. From 6 athletes. Okay. All right. Perfect. All right. It's fixed. Thank you. Now, in how many ways can we choose the top 3 athletes from 6 athletes? So, it's okay. You're not going to say 6 athletes, all right? You're not going to say 6 factorial. What you're going to do for this one, you're going to say you have 6 places, all right? You have 6 individuals to choose from, but you only need 3. So it'll be 1, 2, 3. What is it? For the first place, or whichever place. Maybe you begin with number 1, number 2, number 3, or you start with number 3, you go to number 2, number 1, it doesn't matter. But what you know, whatever position, whatever order you get them, is that for the first position, let's say the first, there are 6 athletes vying for the 6th position, right? Now, one of the 6 wins that position. Obviously, the remaining 5 will be fighting for the 2nd position. Now, one of the 5 wins the 2nd position. Obviously, there are 4 left for the 3rd position, right? So, this answer here will be 6 times 5 times 4, which is, let's see, 20 times 6 must be 120. Let's check. 6 times 5 times 4. Yes, it's 120. So our answer is 120 ways. Okay? Our answer is 120 ways. Now, do you see this one? It's not necessarily using factorial notation. It's somehow still counting principle. Right? So there are 120 ways in which you can choose top 3 athletes from 6 athletes. Okay? Perfect. Now, number 4. In how many ways can we award the first, second, third place if we have 10 contestants? It's okay. Again, 1, 2, 3. What do we have? For the first place, remember we're saying 10 contestants. We have 10. One of the 10 wins the first place. How many are we left with for the second? We are left with 9. One of the 9 wins the second place. How many are we left with for the third place? 8. Right? Therefore, our answer is 10 times 9 times 8. 10 times 9 must be 90. 90 times 8. Oh, Nkosia, hankita. Or could it be 70? Could it be 72? Okay, I'm not sure. Or 720. 10 times 9 times 8. Okay, so what do we have? We have 10 times 9 times 8 is 720 ways. Okay, 720 ways. Okay, it's 720 ways in which we can arrange 10 contestants, or rather we can award first, second, and third place amongst 10 contestants. Okay, I hope this is making sense. All right, guys, so this is the fun of it. Perfect. Now, this one here, it's continuation, the last one, but we're going to have a video for it, specifically for it, okay? But we're still going to do this one, so let's just do it. So we have a family of 4 siblings sitting on a bench. You know, I always struggle with the sitting and the SEA. I had to Google how to differentiate between SEAT and SIT. Okay, so we have a family of 4 siblings sitting on a bench. How many ways can we arrange them if there is no particular order? Now, if there is no particular order, let's look at number A. We have 1, 2, 3, 4. Obviously, if there is no particular order, we have 4 we can choose from for the first seat. One of the 4 seats, we are left with 3 for the second. One of the 3 seats, we are left with 2 for the third seat. One of the 2 seats, we are left with 1 for the last seat. Therefore, what do we have? We have 4 factorial, which is 4 times 3 times 2 times 1, which is 24 ways, right? Which is 24 ways. So this is what you have from the opening video, if you recall. Sorry, from the opening slide, we had 24 ways, right? And this is 4 factorial, all right? This is 4 factorial, okay? Perfect. Because we have 4 objects and we are not limiting them, so we have 4 objects, okay? Perfect. Now, let's head to number B. Don't know why. Oh, I remember I edited. There was number B here, and I removed it. Sorry. There was number B and I removed it. Okay, so let's go to number B. The eldest and the youngest sit together. Okay, the eldest and the youngest sit together. Now, for this one, the eldest and the youngest sit together. We will consider them a unit. Okay, so let's say number B, let's say we have sibling 1, sibling 2, sibling 3, sibling 4. So the eldest and the youngest are these ones, right? So how we can arrange them is the eldest can sit on the left and the youngest on the right, or the youngest can sit on the left and the eldest on the right, and the eldest on the right. So to arrange eldest and youngest together, right? Eldest and youngest together, we can arrange them in 2 factorial ways, right? It is in 2 factorial ways, right? Which is in 2 ways. Okay, we can arrange them in 2 factorial ways. Let me just write 2 factorial ways, right? Because there are only 2 objects. Now, to arrange all, consider youngest and eldest as a unit. Consider youngest and eldest as a unit. Okay, consider youngest and eldest as a unit. Okay, so what do we mean? So you will have, I'm going to show you what I mean. So you now have, I'm going to call them a unit instead of calling them eldest and youngest. So let me say unit, I'm going to say, let me just call it X. So now we now have X, S2, S3. Okay, as you can see, we now have 3 objects. Okay, we now have 3 objects. Now these objects can sit wherever they like. Okay, they can sit wherever they like. Okay, they can sit wherever they like. But I'm going to show you, before I answer this question, I'm going to show you how we get them. Or maybe let me just show you a formula. We have 3 objects. All right. Now, us having 3 objects, what we can do is, okay, unit and the remaining siblings, we have 3 objects to arrange. So, therefore, our answer is for youngest and eldest to sit next to each other. For youngest and eldest to sit next to each other. We're going to say arrangements of eldest and youngest multiplied by arrangements of all siblings when eldest and youngest are considered a unit. Let me show you. So this will be 2 factorial, which is arrangement of eldest and youngest sitting next to each other, multiplied by 3 factorials, because we have said eldest and youngest are a unit, considering that we also have the rest. So this will then be 2 factorial. What is it? 2 times 1 multiplied by, what is 3 factorial? It is 3 times 2 times 1. What is this? This is 2, this is 6, so this is 12. Right? This is 12. I repeat, this part here considers the arrangement of the youngest and siblings. The youngest can sit on the left or can sit on the right. So in other words, there are 2 ways that we can arrange them. As you can see, here are the ways. Now, when we consider the youngest and the eldest as a unit, it doesn't matter where they are. Wherever they are, the eldest and the youngest are next to each other. It doesn't matter when one of them is number 1, the other must be number 2. When 1 is number 2, the other must be number 1 or number 3. It doesn't matter where 1 sits, but wherever they are, 1 must be next to the other. If 1 is 4, the other must be 3, just like that. You get it? All right. So in the next video, we are going to look at this in detail. Okay? We are going to look at this in details because we're going to look at it in manual calculations and in calculations using a formula. But I hope you are okay with this one. All right? So this is it, guys. This is factorial notation. So stay tuned for the next video. Stay tuned for the next video. And I hope it'll be a blast. So this is it. Salang sentle.